Hello, welcome to Suse Conf, and my name is Nivas Iyer. I'm a senior principal product manager here at Dell Technologies. Today, I'll be talking about the data protection solution from Dell, it's PowerProtect Data Manager, and how we can use to protect your Kubernetes and Rancher environments. First, let me go over a little bit about what has changed with application architectures today. So if you look at a traditional application, which is a three-tier architecture, it's typically broken down to web tier, the application tier and database tier. And typically the database tier is comprised of a large, monolithic shared database like Oracle, SQL Server, etc. And that's managed by a central IT ops team. And that comprises of like a storage admin, a backup admin, a database admins, and all of them together, they ensure the hygiene and health of that database and making sure that it's highly available, it's replicated, making sure it complies with the backup business continuity and DR plans, etc. Now, coming to microservices, you can see that these applications, each is actually broken down to multiple microservices. So each microservice is independent, and as a result, each one contains its own database. So they'll have a small database inside each one of them, and depending on the type of data they need, they'll choose either relational or NoSQL database. Like, a relational database might be like a MySQL or a Postgres or MariaDB, for example, and a NoSQL database like a Mongo, Cassandra, or GraphQL, or depending on the kind of application that you have. So now you can see that this paradigm has changed. So all these databases are spread across the cluster. You have multiple of these microservices. You have a ton of these small databases that are spread across your whole entire cluster. And all of these being managed independently by developer and DevOps teams in a self-service mode. And this is the problem that we are looking to solve is how we provide data protection for this distributed microservices environments with Kubernetes. So when you look at data protection for Kubernetes, there are three essential pillars that we look at for solving the problem. The first one being, ensuring that the applications can be backed up and recovered. Of course, recovery being the key. So this protects your applications against data loss, data corruption, and data corruption can result pretty commonly if you have different applications trying to write data at the same time, for example, or maybe there's a corruption in the database in the logic, for example, especially with a CI/CD type of environment. You have an applications are continually being built and deployed, and the database versions need to be compatible. If the database version is not compatible or the data schema is not compatible, then you will end up, with a data corruption issue. So to remediate that, you need to make sure that you periodically performing the backups before you deploy as part of your CI/CD CI/CD workflow. In addition to that, we also look at other things like, for example, you need to meet the compliance requirements. You have to protect your application against any kind of cyber protection. For example, things like ransomware, which can impact your applications. And the second pillar that the application or the data protection solution needs to address is for disaster recovery. So this is a more larger failure. For example, there can be a hardware failure, there can be a site-wide failure, you can have flooding, you can have electrical outage, you can have all kinds of major events that can happen, or even minor events, like for example, hardware failure is pretty common. So in that case, you want to make sure that the data is replicated to an alternate site. You can restore to an alternate site. You need to be able to failover. You create the concept of fault domains. So that's the second pillar. And the third major area for a data protection solution is to ensure that you can manage the data. So what data management here means, for example, you want to migrate the data to a different location, looking at application mobility, which is very common in Kubernetes, especially when you have multiple clusters of Kubernetes and you're moving applications from, say, a dev environment to a production environment. So in all of those cases, you want to make sure that your applications are, mobile. And finally, to look at alternate use cases for secondary storage, such as archival and copy reuse. So all these comprise of data management. So all these three things are the three key pillars for data protection, why data protection is required for Kubernetes. Now, at a high level, the PowerProtect Data Manager is a platform, and it provides protection for Kubernetes, virtual machines, and applications. And applications here means bare metal application, like, for example, if you have Oracle, SQL, other kinds of databases that you're deploying in the bare metal cases. Then also you have file shares, things like that. So it's a complete platform for all the entire enterprise. And particularly for Kubernetes, the application we perform a number of different features that are unique for Kubernetes. So we work within the Kubernetes plane. As you can see over here, the Kubernetes namespace that we are protecting with PowerProtect Data Manager. PowerProtect Data Manager will go ahead and install a couple of namespaces, and these namespaces contain the components that PowerProtect Data Manager will use for protecting these environments. We take now in this case, it's you are using an external storage. You are exposing it via a CSI, which is the common mechanism today, standardized by the Kubernetes community, and also with 1.20 the snapshotting is a feature is GA, or it's generally available. So it's available across all distributions with 1.20. So, and that's also the mechanism that we'll be using here in this example for snapshotting those persistent volumes. And then within the cluster, we also have, data movers that basically compress and dedupe these data before writing it to the backend protection storage. In this case, we can write to, and PowerProtect Data Manager supports, data domain virtual edition, and different kinds of, appliances that can be used for protection storage. Now, in addition to the data itself, you also need to protect additional metadata components for and these can be deployments, replica sets, services, config maps, all the typical Kubernetes environments. And I'll go into more detail in a couple of slides. And there are frameworks for application consistency. And I have a couple of slides later on that talks more about what this framework is in detail. But at a high level, an app consistent snapshot allows the database to recover much quickly versus a crash consistent application snapshotting. While the database will still recover, it will still take some time to recover because it'll still need to read logs, and it has to do reconciliation of the logs and things like that. So we can avoid that with app consistency snapshots. We protect a number of different distributions, and today I'll be specifically focused on Rancher. But there are other distributions as well that can be supported by the platform, in addition to cloud based distributions such as AWS, EKS, Azure, etc. And we leverage Project Valero for some of the aspects, especially and we also contribute to the open source framework for Valero, and we have contributed significant amounts of code to Valero to help improve the functionality, and also benefits the entire community. So let's talk about what enterprise grade data protection means. So here we illustrated some of the key things that an IT team looks for when they talk about the enterprise grade data protection, and also it's kind of how we define what enterprise grade data protection is. So the first thing is the ability to provide management via a user interface. Now here what I mean is like an enterprise grade user interface that can provide a simple dashboard across your virtual machines, your applications, and Kubernetes environments, all of them being protected using a single user interface, so single dashboard to manage your entire suite of applications you have in the enterprise. The ability to have REST APIs to make sure that you can programmatically control some of these functions with and tie it to third-party applications. For example, one example might be tying it to a CI/CD pipeline. For example, you want to take a snapshot of your environments before you perform any kind of deployment. And finally, exposing some of the functions using kubectl. So basically, for DevOps teams, they can use kubectl for performing restores and and tagging namespaces, etc. So some of these functions are available as part of the PowerProtect Data Manager. And there are a number of automation features. So we, while the IT teams may not be fully trained or exposed to Kubernetes, so we have made the process very easily. So when we have a concept of what you call discovery. So when you point it to a Kubernetes API server, and you just we automatically by PPDM will automatically discover all the namespaces there. It'll deploy the components that it needs, and it'll and then there will be multiple restore options that are available for the applications to the same cluster, to another cluster, to another namespace, etc., and also the kind of objects that you need when you're doing restores. The second major aspect is actually very important, is the policy-based protection. So when we talk about policy, a policy is a single definition that includes multiple aspects. So within a policy, you define, how you want to replicate the data, how long you want to retain it, if you want to tier it to a long-term archival solution like S3, and also you can tie it to an SLA to ensure that if your backups and are not being performed in the right backup windows, for example, then they will get reported. Or similarly during restores, you can have SLAs for that. So the idea being that we want to make sure that the applications can recover, and if there is anything that's going to prevent that application from being backed up or restored, as an IT admin, you're going to get alerted about that. It's the backend for PowerProtect Data Manager is Data Domain Virtual Edition, which has been around in the market for quite some time. And one of the unique features that these provide is providing the scale and performance that enterprises need. So it's optimized for either your on-prem deployments, also in the cloud. We have Data Domain Virtual Edition. So all of them provides high performance solution. In addition, because you're gonna have so many data sources, and it's very important to have a very good deduplication and compression to ensure that your storage is optimized. So you get the cost benefits of not no duplicating data. And so we offer source duplication, as you saw in the cluster itself, and also on the target where before it's written, the blocks will be deduped. And we have written our own, like one of the unique features that we have done is added on a agentless app consistency framework. And I have a couple of slides, and that basically provides a templatized version of how to protect these applications. So let's start with a example of a simple application. So in Kubernetes, basically every application has the structure can be different for everything, but typically you have a multiple of these objects that are defined in YAML. So here again we are showing it in a beehive kind of format, but the idea being you have a service that's exposed, and so you have a service definition, then you have metadata that describe how many deployments that you have, and then these deployments in addition consist of replica sets as to replicas of these applications, and Kubernetes will make sure that the number of replicas of your application are always alive. And if any of these application instances go down, KDS will bring them up. And so there are these declarative formats that is available. And then of course, persistent volumes are where the data is actually stored, the part being the compute instances. And in addition to that, you can pass on additional parameters to your applications using, secrets and config maps, again, depending on, the sensitivity of the data. So when you take a snapshot of an application, like a typical traditional mechanism, which is basically just take a snapshot of the database volume or the PVC, using the CSI format, then that's not enough. And let's look at why that is not enough. So let's assume that you have an application and you are taking periodic database checkpoints, and say it's in an hourly checkpoint. So you have 3 volume checkpoints that you have done in 3 hours. And let's say beyond that, there actually has been additional changes to the application. So there have been, not only the data has changed, but also there has been a password change in between. There has been a configuration change. So, but these are not captured in the persistent volume. These are captured in other components of the application. And when you try to restore an application to a previous point in time, guess what? The application becomes inconsistent. So as you can see over here, the colors indicate a database checkpoints, and when you're snapshotting these, you're only snapshotting the PVCs, but the secrets and config maps are also changing. And when you try to, so what we need is to basically be able to protect the entire application, so make sure that there is no drift. In addition to just the application definitions, there are also additional definitions that can be stored, such as cluster role bindings, and custom resource definition. These are more like cluster level components, cluster scoped, and these are important, especially when you are migrating applications. So when you're migrating from one cluster to another, so the cluster roles and role bindings ensure that the application has appropriate privileges, so it functions correctly in the destination cluster. And the CRDs ensure any application features that leverage these resources can function appropriately in the destination cluster. So there you have it, as to the snapshot of all the different components that are protected by in the PowerProtect to protect the entire application, not just the volumes. Um, so let's look at a typical IT setting where you have DevOps admins, you have IT admins, and the DevOps admins and the KTS developers. They are looking at releasing applications very quickly in an agile fashion using CI/CD pipelines. And typically the corporate IT concerns are left to IT, and they are looking for easy restores using KTS native tools. On the other hand, the IT ops is a little more risk averse, and they would, because as they have to maintain these applications and make sure that they are ready to be moved to production, and they pass the compliance test, and making sure that at also the management, they require more like a user interface that's more like a UI based, that's more enterprise wide, and is simple, because they will be managing a number of different environments, not just Kubernetes, but they'll be managing like the VMs, the databases, and things like that. So in a typical IT environment, these can be pretty large, and hence you'll see that you need a experience for each of these constituents in a different way. So they interact with the application differently. So for PowerProtect Data Manager, we offer an enterprise grade UI. So the IT admins can centrally manage all the applications, and including Kubernetes, right, for on-premises and also in the cloud. And for KDS admins and DevOps teams, they can interact with the familiar kubectl, right? Kubectl, the standard CLI tool that teams use. and they can apply, for example, YAML files for doing restores, and they can do labels. They can tag namespace labels so they automatically get protected, things like that. So there are a number of features that we offer for DevOps teams, and we have a number of automation features. We covered some of them earlier, and all of the features and functions that you see in the UI are actually exposed via REST, and hence you can integrate it with any third-party tool, or it's just CI/CD or something else. Um, App consistent backups are performed in an agentless mechanism. What we mean by that is that there is no agent that's running in the database, so it's templatized, and we can be applied, scoped at a namespace level or a cluster level, depending on your use case. We provide default templates, and you can override them. We provide, there'll be a concept of like a pre-hook, and the post hook. The pre-hooks perform, the operations to the database, making sure that all the IOs are paused. With the quires commands, you are, flushing all the data to disk, and basically then you take a backup. And similarly, in the post hook, we unquire the database so the IOs can continue. And it's the same model for regardless of, different kinds of applications that we have. We have a number of applications that we support today, and we continue to add on more and more applications. We support for both standalone environments, but also for stateful sets, such as if you have a cluster, say a database with say one write copy and multiple read copies, we can support that. And so here's how an application template looks like. So sample one. So for example, this is MySQL. So you define, the application label, the type, and you specify the labels. So it will look for that app is equal to MySQL, and that's the standard way in Kubernetes YAML. You define that app, and then you go ahead and then you execute on the pre-hooks and the post-hooks. So again, there'll be a long string of commands that you execute when you do the pre-hook, and you can override it depending on your a particular configuration. And then there are different types of selector terms that you can define, and you can define if it's a stateful set or if it's a standalone, things like that. For example, if it's a standalone, we in the PowerProtect Data Manager would first quires the pod. Pod is the running instance, and you create the snapshot, then you unquires it and back it up. And if it's a little more elaborate, like a source replica type scenario, we would quires the replica pods first, and take snapshots, and then we acquires the source after that. This is the standard, I would say, a best practice for doing backing up of clustered databases. Let's talk about restore to another cluster. So again, this is a common scenario, especially when you're doing upgrades. So say if you have one set of hardware, you're moving to another set of hardware, or if you are moving, any of these components are changing, you can do that. And then you can graduate the applications from, say, a dev environment to prod environment, or if you're moving it to to another location, and things like that. So all of this can be enabled using the PowerProtect Data Manager can facilitate that, the entire movement through the tool. So we back up the entire application and we restore it to another cluster. And also we perform a storage class mapping. So basically, if you have a source database or basically running on block, and you're moving it to a file type storage, we can Power PPDM can specify the storage class mappings in the UI, and you can restore it to the correct target storage class. And so we can restore it to either another on-prem cluster or to the cloud, or whatever is your target use case. And for cloud protection, we have a couple of options in which how you can manage that. One mechanism is that you use your on-prem user interface or basically on-prem PowerProtect instance management instance and connect it to your, the cloud instances. So here, protect all the policies will be defined in a central place. So your on-prem and cloud clusters can manage centrally. And or if you want to manage it by a dedicated instance in the cloud, we also support that. So you can spin up a PPDM instance in, AWS, Azure, Google, depending on your use case, and then you can protect it locally in any of these clouds. And also you can migrate between clouds, so we can support multi-cloud migration as well. Uh, So to summarize, PowerProtect Data Manager, we are very, I would say, kind of like an industry first, providing a comprehensive approach for data protection for not only, your traditional apps, but also for modern applications and virtual machines in a single platform, and also enabling a number of features, including app consistency, high performance, ensuring complete lifecycle management, and etc. And we protect the entire application, as you saw earlier, and we provide a compelling experience to make sure that both IT ops and DevOps and both of them have their own unique way to navigate and manage with the tool. We protect a number of distributions, again, RKE in all the VMware distributions, OpenShift, Diamante, and also protection for Kubernetes in the cloud. And also we leverage Project Valero, but we have a significant amount of functionality that sits outside of it. But we do contribute significantly to the Valero code base to ensure benefits to the entire community. So that's it. And from my side, I hope you enjoyed the presentation, and I look forward to having more conversations. Thank you.